Let's try another example. Let's see one that has us do something a little different. So far we've been given a score and asked to find a percentage or a proportion of the curve that is encompassed between two sections, either a score and above or between the mean and a score. So we can also do calculations if we are given a percentage and we have to work backwards. So what is the score at which 90% of all scores fall below? Okay, so this time, instead of being given a score and starting with our calculation, we're being given a percentage. Again, I'm going to draw my curve because that helps me immensely. So I know my mean is 100, but now I've got a different kind of question. So what this question is saying is if I start at the very bottom and I start taking in IQ scores, how far over do I have to go? So what is this number when I have taken in 90% of the scores? So that means that there are 10% above it and 90% below it. So it's essentially saying the 90th percentile, right? What's the 90th percentile score? So if 90% are from this area, from this line, this score that I don't know, that's what I'm looking for, all the way down to the bottom, and I know half the scores are between the mean and the bottom, how many scores are in this section? What percentage of all of the scores lie in here? Well, I know 50% are above and 50% are below, and I know we've got this 10% piece out on the end that got us up to 90% in the first place. So this section is 40%. So when you're given a question like this, where you're being given a percentage and you're asked to find a score, so our unknown here is the score, this whatever this number is. So when you're given a question like this, what you do is you turn your percentage into a proportion. So that's the first thing. And now I'm going to look up on my chart, but I'm going to start on the inside of the chart and work out. So I am looking inside the chart instead of looking out here at z's, because I don't need z's right now. Instead of looking at z's, I'm going to be looking inside the chart at proportions. And I'm going to look for the number that is closest to 0.4000. And if you've ever played The Price is Right, I typically like to say you pick the closest one without going over. Okay? So the closest one to 0.400 is this one, 0.3997. So this one is 0.4015. It's further away than 0.3997. So this percentage right here, this proportion, 0.3997, now we're going to work our way out of the chart in this direction and in this direction and find out what z-score that corresponds to. So if I go out this way, I have 1.2, and if I go up this way, I have 0.08. So what that means is that the z-score that I'm looking for is 1.28. So that's what this number is, 1.28 z's. But I'm not done, because so what I'm looking for is what the score is at 1.28 z's away from the mean score, above the mean score, because it's positive. So what I do is I'm going to work through this formula a little bit differently this time. So my formula is still the same. Z is equal to x minus the mean score divided by the standard deviation. But this time, the number that I'm plugging in that I found goes over here. So I now have 1.28 is equal to x, which remains my unknown, minus 100 divided by 15. Our mean, our standard deviation, getting plugged into the formula. In order to get rid of the fraction, I'm going to multiply both sides by 15. So now on this side of the equation, I have x minus 100, and on this side of the equation, I have 15 times 1.28, which is 19.2. I need to get the x by itself, so what I'm going to do is add 100 to both sides of the equation. So I now have x on its own on this side and 119.2 on this side. So the score at which, if we go back up here to what we were doing before, it's asking us the score at which 90% of all scores fall below. And that score is 119.2.